Selamat Jatuh. Myself today, my name is Hazim Bin Shaharizuan, and my friend Akmal, Hakim bin Asmi will be presenting DC motors and generators, which is known as in other words called back EMF or counter EMF. Introduction: back EMF. Back electromotive force or EMF, also known as counter electromotive force (CEMF), is the electromotive force or voltage that oppose the change in current which induce it. The back EMF represent as the variable EMF that oppose the one driving motor, known by calculating 0 when motor is not turning, and it increase proportionately to the motor's angular velocity. And then shall move on to the next part by Akmal.
Now we shall proceed to cause of the back EMF inside the DC motor. Okay, as we know that DC motor there's a armature inside that rotates. Okay, within the stator consists of some type of magnet. Usually they are using permanent magnet. Okay, the armature is rotating. Okay, the magnetic field flux which will be cut by the armature, which resulting in EMF induced. So this induced EMF known as the back EMF. Okay, the back EMF acts against the applied voltage that's causing the motor to spin at the first place. So the reduces in the current flowing through the coil of motor. When there's a back EMF, there's a current reduce. If we increase the back EMF or our torque speed, okay, which later I will discuss about the relation of back EMF with torque speed and current and load later in this presentation. Okay, we continue. The direction of the back EMF is such that it opposes the armature current. Okay, as shown in the figure 2, the direction of the source current opposite with direction of back EMF. Okay, now we continue. Okay, as I mentioned before that there's a relation between back EMF, torque speed, current and load. And I've given two scenarios, which the first scenario I've given what happened if we increase the back EMF, and the second one, what will happen if we decrease the back EMF. Okay, this is it. Okay, when we increase the back EMF, okay, at the same time we increase the torque speed, but the armature current and load will decrease. The another scenario is when we decrease the back EMF, the torque speed will decrease, but the armature current and load will increase. Thus, we can summarize that the back EMF are directly proportional with torque speed, while the back EMF are contradicted towards current and load. I shall hand our presentation to Hazim.
Why motors need back EMF? Back EMF is very significant in the working of motors, especially the direct current motors. The presence of back EMF makes the direct motor a self-regulating machine. It also makes the motor to draw as much as armature current as is just sufficient to develop the torque required by the load. That's all from our group. Thanks for watching.